Today we're going to try the principle of moments experiment at home. Okay, this is a really important experiment for physicists, but we're going to have a go using some equipment in our house. So I have a coat hanger and it's a straight coat hanger. If you don't have that, you could try it with a ruler that is just suspended with a piece of string in the middle. And I've just hung it off a hook, but if you don't have a hook, you could actually just get somebody to hold it for you. And I have two party hats. I know not everybody has party hats in their house. I do. But what you could use is some paper cups that are held up with string, or even just some tiny plastic bags. The most important thing is that these two things here do not weigh very much. So don't be using like glasses or things like that. Little tiny plastic or paper bags that are attached by string to your coat hanger works really well. Okay. So what measurements are we going to take? So this system at the minute is balanced, and I know that because my coat hanger is horizontal. Okay, so that is what I'm looking for whenever I'm doing my experiments. I'm going to try and get this thing to balance as much as possible. This is going to be my force 1 when I add stuff. This is going to be my force 2 when I add stuff. This, I am going to measure my distance from where this piece of elastic is attached to the coat hanger to the centre of the coat hanger, and that's my distance 1. My distance 2 is on the right hand side from the centre of the coat hanger, which represents the pivot. Okay, that goes right up to the pivot, and I'm going to measure my distance from the pivot from that point right out to where my second elastic is. So for my first measurement, I'm just going to leave those in the same place, and I'm going to put 2 pens over here. Now, I'm using pens because they're all going to weigh the same. It's just a set of felt tips that my kids have. Or you could use some screws, as long as they're all the same weight, or some dice, or actually the first years did an experiment and they used plums that were all of about the same size. As long as your objects have approximately the same weight, it's all good. Okay, so I'm going to put 2 in here, and then let's see if 1 pen over here, oh, my thing's moved, just going to move that back to where it started, and that's not balanced because this is not horizontal yet, and I'm going to put another one in, and that is now balanced. So now I have to record my results. So like I said, this one here is my force 1, and I'm just going to write now, obviously, you know, I can't measure this in newtons, but I'm just going to write in my force to be 2. Okay, it's probably 2 pens and not 2 newtons, but our table in our books says newtons, so that's what I'm just going to write. Then I'm going to take my ruler and I'm going to measure my distance 1, and that goes from that force where that is attached, which is here, right to where the pivot is, which is underneath it, this crosshair here. And when I measure that, that is 15 centimetres. Okay, now to calculate my anti-clockwise moments, I take my force 1 and I multiply it by my distance 1, and I get my anti-clockwise moment. So 2 times 15 gives me 30. Okay, now let's do the right hand set of measurements. So again, I have 2 pens, so I'm going to write in my force to be 2. And my distance from the pivot, if I measure that, is also about 15. Okay, and 2 times 15 also gives me 30. Okay, now let's do a second measurement, but this time I'm not going to use the same number of pens. So I'll take these pens out first of all. Actually, I'm going to just leave those ones in on the left hand side, and I'm going to move this party hats slightly closer to the midpoint. So I'm changing this distance too, if you like. Then I'm going to add a pen, but it's not balanced yet because it's not horizontal. I'm going to add a second pen, still not balanced, still not horizontal, and then a third pen, and that looks pretty balanced to me, as horizontal as you're going to get it. So let's take some measurements and write down our results. Again, on the left hand side I have 2 pens, and that distance of that party hat from the pivot was 15 centimetres. And then on the right hand side, I ended up with, let's do the calculation of the anti-clockwise moments. 2 times 13 times 15, the force times its distance from the pivot gives me the moment. So that is 30. And over here I have 3 pens. But let's measure its distance from the pivot. And actually that distance works out to be, I'll just move this out of the way so you can see, to be 10. And 3 times 10 gives me 30. So that's pretty good. Now, let's do another one. Again, I'm just going to leave the left hand side. That, if you like, is going to be my control variable, and I'm going to never mind. Anyway, I'm just going to leave that there, and I'm going to add 4 pens. So I'm going to put 4 pens in. So this is the other way that you can make it balanced. That's not balanced. So it's too far down on the right hand side. So I could take a pen out, or I could actually just move this along closer to the pivot until I think it's horizontal. Okay, so that looks pretty balanced to me, and that's going to be my third measurement. So I've kept everything the same on the left hand side. So I still have a force on the left hand side of 2 pens, and my distance on the left hand side, let's just give it a wee double check there. Distance from the pivot is still 15. So my anti-clockwise moment, 2 times 15 gives me 30. And then on this side I have 4 pens, and I'm just going to measure my distance from the pivot. Okay, and that is actually 8.5 centimetres. Okay, so I actually need to get my calculator for that one. Can't do that one in my head, sorry about that. I probably should be able to, but I can't. I can't find my calculator now. Here we go, calculator. And I want to multiply, just take this away so you can see better. I'll just take that away completely. 4 times 8.5, and actually that time it gives me 34. Now, I would like you to do a few more measurements, maybe about 5 or 6 measurements. And you should get a set of results where, when your system is balanced, in other words, when the coat hanger was horizontal, then it should be the case that your anti-clockwise moment equals the clockwise moment. Now that's completely right there. In this case, that's also right. In this case, we've got 30 and 34. So that's not exactly the same, but that's close enough. That's approximately the same. And whenever we're doing experiments at home, when we don't actually have the right equipment, 30 and 34, we could take to be approximately the same. But let's just do maybe 5 or 6 repeats, and if you get at least 3 results where the anti-clockwise moment is very close to the clockwise moment, then you have actually at home proved the principle of moments, which states that when a system is balanced, the total clockwise moment about a point is equal to the total anti-clockwise moment about the same point. All right, girls, thank you.